The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Evolving Role of Technology in Analytics, and our guest speaker for today's webinar is Mr. Rashish Shah. He is Senior Vice President and Chief Information Officer at Fractal Analytics Limited. Rashish is Senior Executive with over 23 years of extensive technology experience in delivery and program management in IT solution and services space. During the past 7 years, his mission has been to scale analytics with quality by providing a big data environment that enables real-time analytics for their clients. Prior to Fractal, Rashish has created, grew and managed a £40 million P&L with high client satisfaction based on trusted relationships and alignment to business objectives. So without any further delay, I introduce you all to our guest speaker. Over to you, Rashish.
Thank you, Gaurav, and it's a pleasure to be here. So today, what I'm going to talk to you all is about the evolving role of technology in analytics. At the outset, let me state that this is not a technology presentation, nor is this a pure business presentation. I'm not endorsing or representing or selling or representing a particular vendor during this presentation. The objective of this talk today is to share a perspective on how analytics is moving forward, trends in the analytics industry, and the role that technology can play or must play in order to achieve the objectives set forth by the analytics or the business team. Hopefully at the end of this presentation, you should be able to appreciate some of the problems that the current technology stack has in order to meet the challenges of big data and in achieving the objectives that business wants to derive from analytics. What are the emerging technologies and why are they exciting for us in our analytics space? What we will be covering today, what I will be talking about today will be about the future of analytics, the analytics sophistication that is there, how is it that the data mix has changed, what are the issues in current technology stack that are present, what are the new technologies on the market that are exciting, and at the end I leave you all with a few recommended courses for you all if you want to get started on this analytics journey. What is it that you should do? So let us take a few examples out here. Do you know that an Italian court sentenced 6 scientists and a government official to 6 years in prison for faulty prediction of an earthquake in L'Aquila? The 6.3 magnitude earthquake killed 309 people and left the city in shambles. How often do you talk to Siri, which is a virtual assistant, using a voice-controlled natural language interface on iOS devices? How is it that LinkedIn and Facebook are filtering messages, your status messages? An American statistician by the name of Nate Silver predicted correctly during the American presidential election results of 2012. He predicted the winners in all the 50 states, and he predicted them right. Pandora allows you to rate your songs, and it also gives you, basis your listening history, it recommends the music that you love and it plays that for you. On Amazon, have you ever noticed that basis your search history, it recommends books that you love or that you might be interested in? How is all this done? All this is done using analytics. And what I'm telling is that this is not the future. the future of analytics is already here. This is what we are seeing in our day-to-day life, and each one of us experiences this out. Moving further, what I have represented out here is the sophistication or the value chain of analytics, how analytics moves up across the sophistication continuum. On the x-axis, you have, as you move from the left to right on the x-axis, essentially you move from standard reporting to optimization out here. Essentially you are moving in from what has happened to why it is happening and when it will happen and what could you do to prevent this happening. On the y-axis, you are moving in from a macro view to a narrow focus. As you go, so essentially, as you are moving from the left-hand side, left-hand bottom towards the top right-hand corner, you are moving in from a reactive behavior to a proactive behavior. We are moving from identifying what has happened to predicting what will happen and further on optimize this behavior. Now to make this happen, one has to understand the relation and the correlation between different data sources. One would want to simulate a lot of what-if scenarios and how is it that the outcomes are impacted. And this is where technology comes in. The computation power required to connect the dots between different data sets and make sense out of the different data, the computation power increases exponentially. This is because we are now starting to deal with the 3 V's of data, which is the volume of data, velocity of data, and the variety of data. Taking in another view, if you look at 5 years ago or 10 years ago when systems were developed, essentially it was all internal data that was being managed. This is where data warehouses were built in and the systems were all used or developed to cater to structured data. About 80% of this data was structured and they resided in the form of ERP and CRM systems. They were data warehoused and kept there. What has happened today is there is a plethora of external data that has now become available. An IDC report states that more than 80% of this data is in some or the other form, unstructured data. What does this mean? This means that the technology stack that was developed 10 years over the last decade was primarily developed to handle structured data. Today, when the entire data mix has changed, the current data technology stack is unable to handle the processing requirement needs that have been placed on it by this huge deluge of data that has now come in. Let us take a step back and see how much data is generated. We all know that a huge amount of data is generated. Every minute, more than 100 hours of new videos is uploaded on YouTube. More than 2.4 million searches are fired on Google. About 2.6 million people update their status updates on Facebook. 1.6 million photographs are uploaded every minute on Facebook. 3.6 million tweets occur every minute. And the list goes on and on. Multiply this on an hourly, daily, monthly, yearly basis. The volume, velocity, and variety of data is extremely huge. Moving on, So if you want to classify the data sources that are going to happen, right, that need to be processed or that are available for processing, essentially we can classify this in 3 buckets. It is either machine to machine, or people to machine, or people to people. When we talk about machine to machine data transfer, essentially we are talking of a variety of sensors, thermal devices, RFID tags, GPS devices, barcode scanners. Devices are linked today over heterogeneous networks with improved bandwidth, making it possible to ensure that data is correctly transmitted and it is captured, and it is very cheap to do that today. On a mobile phone, on a smart mobile phone, there are more than 10 sensors that are there today. Imagine the amount of data that is being generated by a simple smartphone device in each of our hands today. Internet of Things is further generating an unprecedented amount of data, machine-to-machine data today. Moving on to people-to-machine data sources. Today's consumers have a massive data exhaust with the usage of products like medical devices, digital TVs, smart cards, cameras, computers, mobiles. When you browse the internet, for example, this browsing generates a clickstream data, which is then used by marketers to sharpen their efforts and come in with targeted marketing ad campaigns, which is of relevance to you based on your browsing history. Another example of this people to machine, how it is used, is there are sensors that are installed in cars these days. It basically captures your driving behavior, how you accelerate, at what speed you accelerate, at what speed do you take a turn, how hard do you hit your brakes. Each of these are attributes that are captured by this device, sent over to the server, which is then analyzed for generating how your driving behavior is. This information is then used to generate your insurance premium. And therefore, insurance companies today can come up with a much better targeted insurance premium for you as an individual vis-a-vis the traditional way of having insurance premiums calculated basis a few demographic parameters, or such as age and so on and so forth. The next source of data is people to people. Essentially, this is the social media data which is proliferating, and people are collaborating more than before, like we've seen. Like I said, 2.6 million status updates are happening every minute. 1.6 million photographs are being uploaded. How is this information used? Companies use this information to derive insights on how their product launch has spread. And this list will go on. So what is it that we are saying? Essentially, there are a number of the sources of data has increased. You now have machine to machine, people to people, and people to machine sources that are generating this data. To process this data, you now need separate algorithms that will take care of handling these different sources of data. You need separate query algorithms, you need different statistical algorithms, you need different predictive algorithms, optimization algorithms. We need real-time learning algorithms. Man and machine algorithms have come in. Okay. Add on top of that, you now have a different consumption layer that comes in. Consumption platforms are different. Today, we have platforms for smartphones, tablets, you have interactive dashboards. Businesses want simple dashboards that they can understand, which is not technical in nature and which is not too complex. All this is enabled using technology, and technology and analytics are inextricably linked today. You cannot do one without the other. So having said this, let us now move on to what are the issues that are there in the current technology stack. And I would, while there will be many more issues, I will restrict it to only 3 out here for the purpose of this webinar. And my 3 issues that I would like to discuss out here is as follows. One is that the modern databases are slow. Second, traditional enterprise data warehouse systems are not scalable. And third, merging structured and unstructured data is complex. So let us just understand or take a moment to understand why is it that we are saying that the modern database are slow. Like we all know that there are a lot of relational databases. The relational databases are now so widespread that it is hard to imagine a modern company without one. There are a huge amount of technical skills that are required to administer the relational databases, huge number of applications that use them, and this has led to a whole new ERP industry that has come in. What has made these relational databases so useful? Or one of the great advantages of a relational database is their ability to support transactions and guarantee the success of them. And how do they do this? They do this, what do we mean by that? We mean that if we have committed, either a transaction is committed in whole, end to end, or it is rolled back and the entire transaction is rolled back. And how is this done in the database? Essentially, what happens in this, in a database transaction, is that it locks the, whenever you want to update a particular row, what happens? It locks a particular row, it logs the changes that you are making for this update into a separate file, so that it can recover in the event of a crash. It writes the transaction out here, and then it unreleases the lock. This is essentially known, these are also known as the ACID properties of the database, which we all know about. ACID stands for atomicity, consistency, isolation, and durability. While these guarantee the success of a transaction, these are also its undoing for its own self, because these cause a lot of overheads that come into the system. When you look at a particular percentage distribution of where the time is spent in, approximately 20%, 25%, 24% of the time goes in latching of the transaction, recovery for the transaction, writing in the recovery log out here, managing the buffer pool, for finding the right record, maintaining the cache, etc. 24% of the time is spent on the recovery mechanism, which is the write-ahead log. That is, it stores the before and after image to ensure that records are not lost out here. And the useful work that happens is only about 4% of the time. So if you want to increase the throughputs by a couple of notches, you can do that by indexing, fine-tuning your queries, increasing the memory RAM in your server, increase the processing capacity of the server. But if you want to increase the throughput by, let's say, 50x, then the only way you can do that is by eliminating these overheads that come in with the asset properties of latching, recovery, locking, and managing the buffer pool. Otherwise, increasing the throughput is not going to be possible. It will hit a bottleneck at some point of time. Moving on, why do we say that the enterprise data warehouse is not scalable? The reason why enterprise data warehouse is not scalable is because in a traditional data warehouse approach, which is the extract, transform, and load mechanism, what happens in this is that you extract the data from outside sources, you transform this to suit your database store, and then you load the information in your database. It's pretty simple. However, this whole approach is time consuming. One needs to spend a lot of time on understanding the source data. That is, understand the quality of data. How similar are the source and target data structures? What kinds of dependencies exist in the data? How is the metadata used? How complex are the data relationships? It also has people issues because what technology do you build in? What expertise do you build in? Who will support your ETL processes? And you will have technology issues that will come in relating to the volume and frequency of load, how much disk space is needed, to what extent are the source and target platforms interoperable, and so on and so forth. So when you want to add in multiple data sources or when you want to add in a new data source, it's simply going to be a very time-consuming activity. Exercises have shown that a traditional data warehouse might scale up to 25 data sources. Beyond that, it becomes more and more difficult to handle this. Moving forward, structured data and unstructured data. Here is a definition of what is a structured data. A structured data, if you define it, it's a data with high degree of organization. Inclusion in a relational database is seamless. You can search. It's readily searchable by simple algorithms. Unstructured data is exactly the opposite of it. It does not have. It has a low degree of organization. Inclusion in a relational database is difficult. Search in this database is difficult. So how do you merge these two data sets? And why is it that it is complex? So let's take an example. I'll just take an example out here of a company that manufactures beer. And using the traditional sources, it's easy for the company to have customer data and the point of sale data, which is the sales data. I can store this in an enterprise data warehouse, and I can analyze and generate trends in my sales. Where is it that I'm going? Which district I'm selling more? Which region I'm selling more? How is it increasing year on year, quarter on quarter? I can do all this analysis. Now, if you want to answer a business question, which is, did the last cyclone that hit a particular county have an impact on the sales of my data, right? So what we want to find out now, what is the impact that weather has on my sales outcome out here? Does it have a positive outcome or a negative impact? Does it have a positive or a negative impact on beer sales? Did it, are my sales higher in the summers? Did it peak, or what happens? Now this is unstructured data or semi-structured data. How do you merge unstructured data into this analysis and generate your insights out here, which is finding out what is the impact that weather had on my data source, on my sales out here. If you can merge these two data sets, then the whole impact or I can find out, I can generate a better marketing calendar, or I can generate a better ad calendar and target my customers better, and therefore I can have a completely different ROI on my sales. So what is happening is that the old way of managing data is paving way to a new way of managing data. And how is it that's different? In the old way, all the data used to be written on disk. You used to cache data, you used to log the data out here for recovery mechanisms. The applications were written to be multi-threaded, and you would have logging that would happen. The new way is disk IOs are slow. You move into all the information processing is now happening in main memory. You move in from caching to anti-caching, move in from data logging to command logging, move in from a multi-threaded to a single-threaded application, and you move in from dynamic logging to timestamp order logging, command logging out here. This is a new way of processing or handling data that is coming in, that is becoming very, very popular, which is required to deliver the throughputs that the new demands are putting on, that the new data sources are putting on analytics. So with the advent of cloud computing, growing unstructured data, agile development methods, traditional table and relational database models do not satisfy all or most of the data store requirements. The data needs to be distributed, has undefined structures, causing a need to store data in a more flexible formats. Traditional vendors are catching up and coming up with the new way of working. SQL Server 2014, which was released recently, is a complete main memory database engine. Its throughput has increased without changing a single line of code from 10x to 30x without doing anything. All this has become possible because of the new way of working. The NoSQL data stores are becoming more specific and innovative. You now have different data stores that are available to handle different kinds of data. For example, if you want to handle data in the form of documents, you have a huge set of different database stores like MongoDB, CouchDB available. If you are going to handle data where aggregation is going to be a key requirement, then a columnar database, a columnar family of database such as Cassandra or Hypertable would be more useful. They return results in a much faster form. If you want to use information which is connecting different entities, example, linkages across people on the social media, then a graph database format is much better. If you want to use information which is unstructured, completely unstructured, and you want to store that, then using Voldemort or Membase, which is key value stores, which is the NoSQL database stores, are much better. So essentially, these stores are becoming more and more specific and innovative for handling a certain set of problems that we want to deliver to our client, to our business. The last set that I will take in the new emerging source in the emerging technology set is the Hadoop ecosystem. Hadoop 1.0 essentially was more about MapReduce, Dig and Hide. That had its own constraint that was placed out here, because not everything could be done. You could not do real-time processing, you could not do interactive query capabilities, it did not productionize the insight, or it did not do batch processing, reporting, etc. in a well-defined and a timely manner. That was the limitation of MapReduce, because it was the only one algorithm that was implemented on the HDFS or the Hadoop ecosystem. The open source community has worked together to make HDFS much more scalable. What it has done now is come up with Yarn, which is yet another resource manager, and it has delineated the system from the processing requirements out here with the connectivity or the what you want to do with it. So if you look at it now, essentially Hadoop 1.0 had only MapReduce and HDFS, and you could use Hive or Pig. In Hadoop 2.0, with the introduction of Yarn, what it and delineation of the cluster resource management with the data storage, what has happened is that MapReduce is just one component that is now available to do your work. You have different applications that you can run on top of Yarn to do different things. So you have Pig, using which you can write interactive scripts. You have Hive, with you can write SQL queries. You have HBase as a NoSQL database. You have Storm to stream data. You have Spark for in-memory computing. You have cascading for Java, and the list goes on. What this does is that the whole power of doing specific jobs for specific requirements, whether it is streaming or SQL, has been, you've separated and gotten the power of letting the best things do the best job, and Yarn just resource manages the entire effect. Therefore, Hadoop 2.0 is a much more powerful and effective system that is now coming in. Moving forward, if you now want to get started, right? So the analytics space is broadly broken down into two parts. One is the big data engineering and the data science part. The data science piece is all about how is it that I can interpret the data, write statistical algorithms on it, and generate business insights into it. The big data engineering part would be how is it that you can write in the appropriate technologies, or what tools and technologies would you use to enable the data scientists to solve their problems, which we just saw. Whether you would use Spark, or whether you would use Storm, or you would use a NoSQL database, and how is it that you would use this. So there are these two streams in the big data analytics space. And what I've listed down here are a few courses that are there, which are there all in the open source space for programming out here, which is in the data science space, or the big data engineering space, for you to go and you can refer this to help you get started on this big data journey. That is all that I had for the day, and I'll now open it up for questions that you will have.
Thank you, sir, for insightful presentation on role of technology in analytics. Let us quickly take up the question now. I ask you to please read out the question before answering them, so that all our users get commendable insights. And at the same time, I also request all our participants to please share the question with us, so that we can share back to our guest speaker. So we have got our first question. Mr. Assis, can you please check the question tab?
Okay, just a minute. Yeah. So I'll read out the question for the users. When data is being stored which is not single, unique, for example, comment value how it is uniquely identified and analytics performed on it. So that is the whole, I would call it in the form of an unstructured data which is coming in, and that is the whole power of how is it that you could connect the dots. So taking the example of the weather data earlier, right? How is it that you would connect the weather information along with my sales information? And there are direct and indirect ways in which you would do this of connecting the dots. Taking the weather example out here, what we could do is that we could layer this on a timeline series, find out the highs and lows during the day on a timeline, and then plot the timeline with your sales impact or the sales on that particular day, and then see if you can find a correlation of the increase or decrease in sales on that particular day out here, and generate an insight of whether the high temperature or the low temperature had any impact on sales on that particular day. So essentially in this particular, to answer your question, what we would need to do is, if it cannot be directly associated with the data, then you would have to find an indirect way in which you could correlate the different variables with your data set and then use it for generating insight. I will move on to the next question. Which kind of algorithm will be used for analytics? This is a very broad question, and the way I would answer this question is that it depends on the business problem that you are attempting to solve, and to solve that particular business problem, you would use the appropriate algorithms out here. If I want to do a real-time processing out here, let's say if I want to find out what is in the case of chat shows, for example, where there is a lot of voting that is happening, and then I might have to come up with, because the number of inputs that are happening are very huge, I would have to implement probably a machine learning algorithm to find out the insights in that particular data. So it depends on what is the business type of problem that you want to solve, and what is the volume and variety, what is the volume of data that is coming in to solve that particular problem. The next question is about statistics. How much statistics knowledge is required to move in big data analysis or analytics? More than statistics, I would say that to move into the big data analytics space, one needs to have a combination of 3 skills. One is the business knowledge, understanding of the business knowledge. Second is statistics, and third is the engineering skills. A combination of these 3 is required to move into the big data analysis or analytics space. Depending on the level of analysis that one is doing, right from, if you're doing a reporting, if you remember on the continuum that I had shown of the analytics continuum, as you move up from the bottom left corner to the top right hand corner, the requirement of statistics will keep on increasing. And you know, so to answer your question, how much statistics is needed? You would need some amount of statistics, but if you want to get started with this, a basic knowledge of statistics is required. But if you want to get into the predictive model space, or if you want to get into the optimization space, then you need to have a very high degree of statistics knowledge that is required. The next question is out here, which tool would you suggest we start with in order to learn analytics or analysis? R, Hadoop, IBM, Spaces, Stats. My recommendation is start off with R out here to understand how the stats is processed. At the same time, you need to understand a little bit of business and out here. So my recommendation is to start off with R because that is open source. SPSS is a licensed version. R, Hadoop are open source, and I am a believer of open source out here. So I personally prefer R and Hadoop out here. Can new generation data discovery tools support predictive analytics? Naming such tools will help. There are a lot of data discovery tools that are available that support predictive analysis. I would not want to name a particular tool out here because there are different tools that are available to solve different business problems out here. So I would not want to name a particular tool out here. Can real-time analytics be implemented on Hadoop? What tools will be required? What tools will be required as MapReduce or Pig may not be suitable? So real-time analytics can be implemented on Hadoop out here. You would need to use Spark, for example, because that would be an in-memory tool out here. So using Spark, one could generate real-time analytics insights out here. RDBMS folks are telling discovery and predictive analytics are simplified well in today's states with existing traditional systems. Can you comment on it? The answer is true. RDBMS folks are getting onto the bandwagon because they have understood that the way they were currently processing the information had its own bottlenecks, and like I just suggested, right? SQL Server 2014 is an in-memory database engine. HANA from SAP is again an in-memory database engine. Oracle is coming up with an in-memory engine. So a lot of these folks are all changing the way they are processing the data, or they are handling data out here. So answer is yes. RDBMS folks are coming up with new versions of tools that are enabling predictive analytics, are supporting predictive analytics today. How is the industry shifting towards big data analytics over conventional analytics? The industry is shifting towards big data analytics. The challenge that the industry is facing is how is it that we can get in different sources of data under one roof, and how is it that we can merge the data, the disparate data sources, given the volume that is being generated today. What should one use? That is the challenge that the industry is facing. So that while everyone is shifting towards data analytics, it is slightly slow, but it is gaining momentum. After around 17 years of experience, what should we start in big data analytics if one is not too much technical? The way I would say is that if you're not too technical, then the best way to start off analytics on this analytics journey is getting started on the reporting journey. Move on. Once you understand, getting onto the reporting journey would enable you to understand the business, how is it that business interprets these reports? Number one. So that is what it will help you understand the data that is there, how the data is interpreted. Once you get onto this and you understand data, then getting on to the statistics part, and it's easier to start playing around with data, connecting the dots out here using statistics or simple techniques. You don't need a whole set of statistics to get started, but a simple understanding or a Stats 101 course is good enough to help understand the relation and correlation factors that are there out here, and you can then start connecting the different data sources. So even if one is not too technical, it will be slightly challenging, but that's the learning curve. One will have to go through the learning curve and then get started on the analytics journey. I think I've already answered this. The next question is, RDBMS folks are telling discovery and predictive analytics are simplified well in today's trade with existing traditional systems. I have commented on that. The next question is, what is your view of reporting versus analytics? As most organizations still does only reports, not analysis. Your view is appreciated. This is a journey. The way I would answer this is that analytics is a journey where you will start on from reporting to reporting. So the way I would answer this question is that there are different organizations which are at different levels on the analytics maturity curve. You have organizations such as Google and Amazon, which are on the top right-hand corner, which are in which analytics is highly institutionalized, and is highly institutionalized and is highly advanced. That's one end of the spectrum. Then there are other organizations where analytics is started off with a reporting. It is there in specific departments, or it is there across the organization in the reporting form. So either you have specialized analytics but it is in spurts out here in departments, or you have reports that are there institutionalized across the organization. So what happens is that the first step is reporting, and then as the organization starts maturing, it starts moving towards more and more predictive analytics. As it moves across as it gathers experience in that, in institutionalizing it, it moves in more towards the optimization part. And there are quite a few organizations who are still at the bottom left corner out here, and therefore what you see is reporting is more predominant out here. So my view on reporting versus analytics is it's a journey. It starts off with reporting and it moves in towards more of predictive analytics, and it further moves on towards optimizing analytics. The next question is how analytics would help to build intelligent systems. I think analytics is the core to building an intelligent systems, and we have seen quite a few examples of this, which is there in Amazon, for example. When you go in and browse a fictional book out in Amazon, the next time you go and browse on Amazon, it goes in and suggests a few more books which are in the similar genre out of a fictional category. All this is done using analytics. The examples that I gave of a Google search or of Siri, all this needs a lot of analytics behind it to come up with the right or the appropriate answers for the same. And that is what we call it as an intelligence system. So analytics is the bare bone for building an intelligence system.
So I think we are done with the question answer part.
Okay.
And I'm really thankful to our guest speaker for taking so many questions and conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on our website, that is techgeek.com, by tomorrow. Thank you all. Thank you, Rashish.
Thanks, Gaurav.
Thank you, sir. Have a nice day.